VR hardware manufacturers often talk about field of view values in degrees or use abstract marketing terms like ultrawide and similar expressions. Numbers tend to appear objective at first glance. They are meant to help potential buyers make better decisions based on seemingly clear specifications. And many people naturally interpret higher FOV values as being better than lower ones. At first, this sounds plausible. A larger field of view in VR should mean that you can see more and that it comes closer to how human vision works in real world. But unfortunately, it's not quite that simple. This video is aimed at people who may have had their first experiences with VR and want to understand it more deeply, but also at those who are already more experienced with VR and are interested in new ways of thinking about this topic. Hi, I'm Stefan, your VR accomplice. Enjoy the video. Why FOV specs alone don't tell the full story. People who have been involved with VR for a while are familiar with the specifications. Some may have heard terms like horizontal, vertical, or diagonal field of view. All of these refer to the visual field in VR that is delivered to the user's eyes through the interaction of displays and lenses. Horizontal FOV describes the width of the visible image, vertical FOV the height, and diagonal FOV the line from the upper corner to the opposite lower corner of the image. While I generally find horizontal and vertical FOV values useful for basic orientation, diagonal FOV can be quite tricky. I have already seen cases where manufacturers omitted the additional label and simply stated a single FOV number, which in reality referred to diagonally measured FOV. Since diagonal values are always larger than horizontal ones, this can be misleading. I don't want to accuse anyone of intentional deception, but it is at least a simplifying presentation that can lead to misunderstanding. Now, let's talk about binocular overlap, also known as stereo overlap. As humans, we always see the world from two perspectives at the same time. One from the left eye and one from the right eye. What one eye can see at the outer edges of the field of view, the other eye can no longer perceive. The inner area, however, is seen by both eyes, albeit from slightly different angles. This is what creates spatial depth perception. The same principle applies in VR. That's why a higher binocular overlap generally leads to a better 3D impression than a lower one. If a manufacturer provides this value, it can definitely be worth paying attention to it. Values around 70 to 75 degrees are often considered good, but more is generally better. For some people, a low stereo overlap can lead to faster eye fatigue because the eyes have to compensate for this imbalance. It also results in a less pronounced sense of depth. Another important point is that the subjectively perceived FOV experience does not depend solely on what a VR headset is technically capable of delivering. It is also strongly influenced by facial shape, eye position within the head, interpupillary distance, and the distance between the eyes and the lenses. As you can see, this topic is quite complex, and individual experience is always subjective and never 100% comparable between different people. Let's talk about measurement versus perception. If you own a VR headset, how can you actually check how large your personal field of view really is? The headset itself doesn't show this information. Instead, you need specific software tools to perform these measurements. I use these tools in my own tests, and I'd like to briefly introduce them here. Test HMD. This is a comprehensive tool that allows you to measure not only horizontal and vertical FOV. The downside is that it costs money. In return, you get a fairly extensive test environment and a quick, solid overview of your field of view. WimFOV, or What is my FOV? As the name suggests, this tool focuses exclusively on measuring FOV. It is free to use and measures very precisely. One particularly nice feature is the clear visual representation at the end, which shows the field of view for each eye individually and also calculates stereo overlap. This is my personal favorite, as I find its results to be very accurate. HMDQ. In combination with the other tools, HMDQ is an excellent addition. It allows you to read technical values directly from the headset's firmware, including the maximum possible FOV. You can then compare these values with your measured FOV to see how much the theoretically available field of view actually reaches you. These tools are mainly interesting for people who want to dive deeper and better understand their headset. They are not necessary if you are simply happy with your VR experience. But if you've made it this far in the video, I assume you are probably among those who enjoy understanding their hardware in more detail. What really matters instead? We've talked a lot about numbers so far. At the same time, I've said that VR experiences are highly subjective. So we are dealing with variable values and relative measurements. How then do we recognize a good VR experience? Immersion is not about seeing more. It's about the brain being able to trust what it sees. This has partly to do with personal preferences, but above all with what feels comfortable to you. No one wants eye strain or fatigue in VR. I once had a very extreme experience with a pre-production test headset that wasn't properly configured on the software side. When I took it off, my eyes needed several minutes to relax again because it felt like I was cross-eyed. This is an extreme example, but it clearly shows how the eyes and brain automatically compensate when something feels off in VR, and how fundamentally that degrades the experiences. Some people are also particularly sensitive to low stereo overlap, probably because it deviates too much from natural vision and simply doesn't feel right to them. Again, the eyes have to compensate. In addition, low stereo overlap reduces depth perception, in other words, spatial vision. And in fact, with VR headsets that offer an especially large field of view, this has so far always come at the cost of stereo overlap. In the end, the only way to judge this is to try it out and see how it feels for you personally. Many people also find it pleasant when a large central area of the image is rendered sharply. This is often referred to as a large sweet spot and good edge-to-edge clarity. When this is perceived as good, the sharp area feels comfortably large, so you don't have to search for clarity every time you put the headset on. Different priorities are valid. What we see, then, is a wide range of subjective VR experiences and equally diverse needs when it comes to immersion. Some people want the largest possible field of view, others prefer an evenly sharp image, and for others, a particularly stable and calm visual experience is most important. In PCVR, there is another group for whom the optimal balance between available PC performance and headset demands is key in order to achieve smooth gameplay, while render resolution is considered secondary. One thing they all have in common: no one wants the feeling that their eyes and brain have to work excessively hard to maintain a coherent VR experience. This is influenced both by prior personal VR experiences and by individual expectations of what VR should feel like. The conclusion: when you put everything together, one thing becomes clear. Field of view is not a number you can simply compare. It's the result of technology, perception, and personal priorities working together. Two people can use the same headset, measure the same values, and still have completely different VR experiences. And that's why immersion isn't about always seeing more. It's about what you see feeling right to your brain. Understanding this helps you judge hardware more realistically and approach VR with calmer, more grounded expectations. If you're interested in why VR feels the way it does, not just in numbers and specs, you'll find that perspective regularly on this channel. Take care and see you in the next video. Tschüss.